You want a coffee or you want me? Okay.
Sini punya orang banyak pakai Mitsubishi juga.
Sini bukan banyak.
Omron Mitsubishi kan?
Sebab cheaper kan.
Ya kan?
Tapi memang banyak yang pakai Omron Mitsubishi. Cheaper, reliable.
Cheaper, reliable.
Saya tak pernah pegang untuk PLC.
Ya mana? Yang Mitsubishi.
Sebelah tengok tapi saya tak pernah.
Apa yang sentuh?
Tak pernah sentuh lah.
Mitsubishi ke Omron lah. So Omron new one tu. Ni Omron lama. This one using CX programmer lah. This one. It's easy also the software. It's like
Straightforward.
easy to learn. Yes, straightforward. And this one a new one is using Sysmex Studio.
Siemens Studio.
Okay. I don't like the software because the software interface is black color. That's the only reason lah. Okay, because other software, because it's for me lah. For me, I need white color, bright colors. This one, the programming, the functions, everything similar to TI portal. The timer, the timer block, because this one is totally different lah. Okay. For this one, if you see the timer, the counter, the functions we are using in TI portal and also inside here, look exactly same.
Exactly same.
Yes.
Okay.
So this one I learned myself.
See.
So when my boss buy this one, the last time one training, my boss buy one, then he asked me to test lah. So I go to YouTube and test, then want to check all the functions I know in other PLCs, want to check here. I see, look like same only. Then I do a simple program, it's exactly same like TI portal. This one. Same goes for Mitsubishi also. This one is a older model lah.
This one older model.
Older model. So there is A is the older model. This one is GX developer software. Then they have another one called Q. Q, that one is using GX Works 2. So this model also same, using GX Works 2.
This one is not modular, right?
This is the modular.
Modular.
This is compact.
Compact.
Okay. Then a new one, latest one, they use same like this, because for latest one they have something like modular and also compact lah. The modular they call R series. Okay. Then this is the compact. This one using a GX Works 3, the software. This software, the timer, the counter, the functions are similar like Siemens. So if you already learn TI portal, you want to learn this PLC, the Sysmex Studio is actually same for you. Because this one also I learned myself using YouTube. Then I go and explore, then I see, because the software wise is similar to the previous version. So software wise for me easy lah. But the functions I want to use, right? I see, it's not similar. Same thing. So it means that they like standardize. All the ladder must use the standardized ladders. Better. This one is a Panasonic. The programming. This is also Panasonic. Small one, just 8 input, 8 output. This one similar to the software, the I/O points, the addressing same like Mitsubishi.
Okay. All Japanese company.
In Japanese.
But Panasonic is not that famous, right?
Not that famous.
So for Japanese brands, usually Omron and Mitsubishi.
Omron and Mitsubishi, because high speed controls, all that can do. But sometimes I've seen some machines using small system like this big. Okay, like 20 input, 20 output. Yes. Panasonic. But this one can add some more the I/O.
But this one can add on for remote.
Remote.
For remote line, can right?
Okay. This one. Because
Compact model.
can.
Can now.
Because this support CC link.
Oh, 60.
Can support.
So if let's say my input or output is not enough, then I can look into
Yes.
another remote line.
Yes, can.
Oh, okay. That's good.
So sign the sign the
What is it?
Then this one, ours. This one,
What brand?
BNR.
BNR.
This one is Europe brand.
Euro brand. But not famous.
No, because this one is for last time famous lah. This one last time when we replace the system, upgrade. So take out the old PLC, put a new one lah, which is familiar for us lah. So that time we take out this one. Take out this one.
This brand we never see.
Yeah. This one also got IDEC. IDEC also is like a compact PLC.
Actually, a lot of brand, right?
A lot of brand.
Only thing is but this brand is getting famous, right?
Kians, yes. Yeah.
I think
Kians.
so.
Actually,
Japanese.
Japanese, but Kians is already famous for their sensors.
Oh, sensor.
Yes.
Production sensor.
Yes.
Okay.
Already famous for the sensors. Some of the vision sensor can cost you like 300,000.
But the best sensor, what is right?
Depend on the sensor types. What type of sensor? Japanese means I think Kians. Japanese means Kians. If Europe means I think SIG. We have also SIG, but normal sensors lah. Europe means SIG. That's another one I can't remember.
These are
Yeah, of course. So then the transmitters means like primary transmitter, flow meters, all that, then endless houser, all that. Yes. Honestly, I want to see what happened. Yours are there's two more input need to connect.
yeah, just
Later want to do some project. Whatever. You can run so that your run is not disrupted. Okay? Or disrupted. Oh, okay, because this one of course because the last one missing. When you do this one for the control logic, yeah, it won't disrupt.
Go for the control logic.
Yes, yeah, it won't disrupt.
Only for the compact.
Yeah, only for the compact because control logic is running on base, right? So when you add new one, it won't affect. When you remove only, it will affect. This one now the problem is why? Why the error? It's not not because of this. Because of your end cap is supposed to connect to here. Yeah. So that's the reason lah. Okay.
So if I
You can click here. Is what is OW16.
So, every time we save, inside it consists of three file, right? ACD file.
Got 3 files left
Over here,
with the same name lah.
another three different name.
Yeah.
So many standards.
So yeah, I
The filing system.
because it's always do a backup. Okay, because of
Three. Project file, we have file.
wait, okay, 4 years ago. Okay, now day 1 lesson 1. Okay, because you remember yesterday we do some conversion, right? From 32E to 35E, the CPU convert. So that's why these two,
Correct.
these two lah. Okay. If no, normally you will have all these four. Okay.
Okay.
This one is because your project is open, right?
Temporary file.
Temporary file lah. After you close, this one will close. Okay.
Uh,
So normally you will have these three. Okay. So this one is the last save. Okay.
Yeah.
So this one the previous saving. So it will always keep 3 files, then keep on update. So just now it's a 9, 8, 10, 11, right? So this is the 12th one lah. So let's say again I save, this one become 13 1, then this one become 12, 11, 10. If
It
you
depends
see,
on how many times you save.
yes, you can see when it's saved.
So the number keep on changing.
This number keep on changing lah. Always keep three backup.
The last one, the fourth. Yeah.
Total 4. This is the last one.
Okay.
Then the previous 3.
Okay. I see.
Why I cannot add this one? This can. Let's say there's a port here.
Which cut?
The last cut.
Okay. Okay, we see what happened. Okay. Now, so you want to add a module, right?
Yeah.
Okay. So you already added here, okay? And you want to download it,
Yeah.
correct?
Yeah.
Okay. When you want to download, because the PLC already in the error, fault,
Okay.
already fault. So you need to clear the fault.
I already played this now.
Okay. Wait. Let it become programmable. So you go to remote. Okay. Wait. Don't delete. Okay. Okay. Close. Still faulted. Still the fault is there.
Yeah, I said for the
Okay. Am I click here? Because I think the last your end cap is not connected. You connect the end cap first. PC. Same. Both the same platform. Okay. Now go to fault. Okay, also here also same thing. Okay. Now clear, it become a program mode, right?
Yeah.
Now you can download. Because you are online, so that's why you can download. That's why you go offline and download. Okay, then you need to run manually. The run mode. Go here. still locked. Okay. Now you download the. Wait, don't do anything. Yeah. You already downloaded the program, right? But it's a fault here. Okay, actually, you can clear the fault here also. You know, right?
Yeah.
Go to program, run, program again, run again, and go to remote. Two times. First, go to program. Stop lah. Stop. You can try. What do you do?
Macam ni buat API.
You pernah buat lah.
Itu saya cuba je.
So you can try first. You remove this connection first. Okay, your last is not connection. The bus, white color. Okay. So you want to test, you just remove one, and you can test.
You mean remove this one?
The bus. Remove the bus. Push down. Yes. Then go to. Yes. So now got error. Okay. Now connect back. Because okay.
So I have to continue.
Yes. Program, go to remote, and go to program again. Okay, to become a program mode. Done. Then go to run lah. Enough actually.
So right, usually let's see other operation is
Put into run also can, remote also can.
running.
Yeah. Why? Because remote means then only I can access to my laptop. Okay. If you don't want other people access, you just put to run, record.
Yeah.
So normally you do that, right? Okay, good. Okay, good. Then what you do? You create a new project. Day 2 lesson 1. You create new project and you add your PLC, your IO cards. Then in the tagging, you add in the tagging you just add P push button 1, push button 2, push button 3, switch 1, switch 2, switch 3. Then lamp you can put like lamp 1 to 6. L35, yours is L35.
Just now what? Push button what?
Just put PB1, PB2, PB3, then switch 1, switch 2, switch 3. That's okay? Okay, now right click here, compact bus continuous. This is where you need to add.
So the tagging we need to use 6 tagging. What to?
No. Edit tag. Okay, down here. Edit tag. Down here. Yes, this is where we add the tagging. Let's get active. Let's put PB1, push button one and PB1. Okay, enter. Then alliance for here. Okay, local R1I data 0. Yes. Then for output, level 1 to level 6. You see, for C, right, I have output input configuration. C means configuration. Okay, you open. Oh, never mind. Okay, never mind. Because you add for the 2O first, 2 output first. 2 output, 2O. Yeah. 2O data is 0. Never mind. Later you can add for the others. Okay. You see here for the configuration. So, these are the configuration data of your output card. Okay, so if the if the module is fault, right, then here I can know the module is fault because it's a boolean, right? So here it will get the value like 1. Then I can use this for my programming. So I can use this, okay, to show, okay, this module is faulted. This module is faulted. Okay, then here program mode. Click here. The local 2C program mode. Okay. So during program mode, what happened to this module? Okay, so there is some settings for the card actually. Okay, you right click the card because for this one and this one you can see. Go to properties, you bring to this side, this window, bring to this side. It's correct, not problem. Okay. Yes. Okay. So you see program mode and fault mode. Right? Okay. So output state during program mode and fault mode, you can choose what happened to your output. Okay. So if I on this one, I can on and off like which one I want to on and off on and on. So the result will be here. This program mode and this fault mode. So I can use this data. So if the suddenly faulted, right? Because fault or program mode, all your output is cut off. So we can use one of these to give some data or some signals, some alarms. Yes. Later you can try this. Okay. So that is for for output card. So you have a normal output and also this configuration because the fault and everything. Okay. Close. For output card, there's an I also. Right. You close the local to C. Can you see for output card? There's a 2I. Okay. You click that. So it's a fault and read back. Okay. So fault means same lah. If I have a fault, I will show the fault here on the card. Okay. Read back is if the if the wire break, some of the data lah you can get from here. The one you need to refer to this manual, this hardware. You need to go to this manual. Okay, not exactly this lah. You can go for the 1769 hardware manual.
So basically for output we have output, we have configuration,
and also input. That input is like a fault data.
So for the inputs usually how do you use?
For this one, the local, we can see the fault actually. Once you've done, okay, what you do, you finish the lamp until 6, then you download first, you go online, then we try to remove the last card and see what we get here. So on the input we can get the fault.
They want by default, right?
By default, okay. The output, right, the O is user defined.
Yeah.
Okay. The configuration and the I is the hardware already defined for you.
But we can do some changes.
Yeah, of course we can do. We can use that information. Because it's already okay. What I mean is for output local 2O data 0, okay. It's a lamp one, right? Because we configure this.
Yeah.
But in this case, they give like a fault. You open the fault. Okay. So they have 32 faults lah. So each one they have their own meaning. So we can configure that. So this fault is for module fault. This fault is for wire break. They already give you
pre-configured.
yes. They already configured for you. But so what we can do, we can use that particular information.
Okay.
You finish the lamp until 6.
Can you explain this one data types?
Data types. Okay, because this one is about the one with the AB part number because it's the module lah, right? Okay. So we have an integer, double integer, and boolean for 3 types. Right. So if you go to my manual, you go minimize this. Go to my folder. Elaborating. Numbering. Later is 2, right? Just now on the top got 2 folder, right? Nilai and something good talent. It's actually company program. Later you can see. Okay, go down. Go down. The last one, I think. Okay. Data types. Oh. So data types is what are the data the PLC can read like. So the PLC can read bit,
Yeah, yesterday.
which is boolean, right? Okay. Then 8-bit, no, 8-bit don't have elementary because this one for all the PLC lah. Okay, but elementary not using 8-bit. Okay. Then we have a 16-bit, 32-bit, and another 32-bit is for real. Okay. So in the elementary they use 32-bit. You go to your model. Because just now your cards, right? You see your input data is double integer because you have 32-bit. Correct? Your input is 32-bit. Okay. Your output is an integer. Your local 2O, the 2I you close. 2O you open. So the 2O data, can you see, is an integer here. Because you know why? Because inside here I got 16 bits, 16 inputs. Okay. So this double integer, this integer is represent the number of I. I would like to show you that. Okay, to show the number of I you want to use. Okay. But later when you want to use timer, then only we will be using the values.
So basically, for family treat that, right? With the whole.
Put so many times. So many times, but as a value, because as a value we have a boolean, integer, double integer, real. This four main.
So the other integers is the degree.
Yes.
Oh, because
Yes.
the card itself is 32, right? Like output card is 16
16. Integer.
integers.
Yes.
Then individual output is a
Boolean lah.
because
One.
it's 1 and 0.
Yes, correct.
Okay.
Even shift to all to relay output it.
Yeah.
No, not this one. Just like this.
Is it works?
It works. I know this.
What is? Data 1. You know, in Siemens, in Siemens, the name is in sequence, right? 1, 2, 3, right? And Excel you can track.
Oh, you can put up.
Yes.
Oh, I see.
But as far as I know, that one is only available in TI portal. Other brands I tried cannot.
Yeah.
Even like I said, the Siemens Studio, all new software, right? Same cannot.
So usually, what is the field that is more complicated than more programming?
Complicated. Programming is really what field?
Have you seen a huge spectrum? There's a lot of complex logics, most complex logic.
Yeah, most actually complex.
They're trying to
Manufacturing machines, big manufacturing machines, because others like oil and gas, all that, like mostly, was more to like collect data, like more to analog control, like temperature, pressure, collect data, control. Controlling is just normally what oil and gas, controlling what valve, open the valve, close the valve, right? On the pump, off the pump. So mostly on that one. So it's actually easy compared to manufacturing. Manufacturing, because you have a conveyor, you have a servo motor, so you must be positioning. So that one got so many interlocks. So that logic would be difficult.
complex, right?
Yeah, complex. But for me, the most difficult part is the networking. Yes. Communication, networking, communicate with this device, communicate with this device, all that. Because so many types of communications. Because just now I see in your yesterday you show your system, right? Got so many communication types.
Yeah.
Normally internet IP you have, then I see got any bus.
That one is for canvas.
Oh, CAN bus, yeah.
Canvas over to an internet.
Yes,
Two protocol that
yes,
talk differently.
yes.
Semalam ni orang tempat the one because the rise using the wireless system.
Yeah, so I say the communication, how you communicate with the device. But if you want to learn, that's the thing that you need to get the devices to learn. Then you can understand.
But even the more complex programming, right? Still using the or it means
Mix, of course, mix. They use ladder, they use the function block, they use structured tags, all these things. So I say, function block. Yeah, sometimes they use function block for some logics. Okay, logics, of course, are function block and ladder for creating logics. Okay. Structured text is more for like calculation, data movement, data comparison. Because let's say I have like 100 data, I want to compare with 100 data. Okay, for example, because sometimes some manufacturing system, right? Because okay, like this, you come here, you will scan your barcode and you will arrange. So means here one barcode. I go and arrange, let's say warehouse. You send a product, so it will scan the barcode and it automatically arrange to each, right? Here one barcode, but I need to scan with hundreds of barcode in your system. So that I can use ladder to do the scanning. Means how I want to go and compare one by one here. So in that case, I do a structured tax comparing.
You need a table, right?
Yes, so I will get like I will put if it's in Siemens, I use a data block. They call data block. So I use a data block to scan all. Then in the data block, I keep all the data, all the barcode data. Okay. Then whenever this one comes, okay, I compare. Then I know okay which rack to do, which rack to do. So in that type of programming, I need to do structured text. Yes, if I do later, then I will do like very big program. Difficult also, because one by one you need to compare, check.
Every single time you scan, you need to put
Yeah, one by one, everything. So if I structure like this, okay, I can do some program that is, I take the data, compare the whole set.
the whole table.
Yes, the whole table. So okay. So depend on the programming. So that's why sometimes I do project also. The normal sequence lah. When this one on, this one on, this one off, like that, right? I use ladder. So whenever calculation involved, like calculation, analog calculation, all involved, then I do structured text. That's how I do.
But mostly these two enough.
Normally for me I use normally this two lah. FPD I very rare I use. But German people like use FPD. I don't know why, because last time I have one participant, he's a Malaysian guy, but he studies in Germany. So he studies in Germany, mechatronic I think. Then there's one course for Siemens, Siemens course. Then he do a practical in Clan. So he come down here to do a practical lah. So before he join the practical, he come for the training. So he come and attend TI portal. Then when I do training, then only he told me lah, okay, he studies in personal, right? So then only he told me he studies here, studies in Germany. Then he said they teach him PLC, but they didn't teach new one, you know. They teach the old system, the semantic manager with the S7300, and they teach them function block diagram. Yes, they didn't teach ladder. I was asking him why. Then he said he also don't know.
This
Maybe yeah, because that's why I say function block is like similar to the gate, AND gate, OR gate. And last time when during our study time, we studied that, something like that. So maybe they use that format, the AND gate, OR gate, that. So for them, if they teach the function block diagram, it will be easier. So he come for training. So I teach him ladder, so which is totally new for him lah. But he is good at addressing because he already learned the addressing. Okay. Alright, so this one okay. You enter. Okay. So no worries, later we will learn the double integer boolean. Of course, because in PLC most important is two things, you know. The logic is different. Okay, the logic is you need to improve lah, right? Okay. In programming, there's other two things is important, which is the addressing. Okay, addressing. So in Allen Bradley, there is no address. They call tagging lah, right? Tagging and the alias. Okay. Then number two is the data type. Whether it's the boolean, integer, double integer, or real. Yes. These two is very important. So whenever we do program, you will be rely on this tool. No worries, later we will go more deeper. Okay. So this one done already, right? Yours is okay? Okay. Now what we do?
But if let's say the whole card, right? The data type is the DB. You see local one.
Yeah. Because it's just showing the the part number of your of your card. They say, not part number actually, they say 1769 is the model number. DI32 is what card is that? It's a digital input 32 card.
It's just an information line.
It's just
not,
information.
It's not the data tag.
No, data.
It's not
Don't
the-
confuse with that because it's good. But it falls under the data tag also lah,
Yeah.
for the card. Yeah. But the important one is basically see this one. The one we key in, I want to say data tag. Okay.
Okay.
Okay, what you do, you open the main program. Open plus. So yesterday we see right main program, main routine, right? Okay. So normally in main routine we very rare do programming in main routine. Okay. So we will be doing programming in subroutines. Okay. You right click the main program. Okay. No, main program. Yeah. Then you click new routine. Okay. Then the new routine, you name it as latch, unlatch. Latch underscore unlatch. Yeah. You don't need to underscore it. When you give space, automatically, right? Okay. The data, data type, the language type we use is you click here, ladder lah. So later will be you click here. Okay. So later we will be learning function block and structure text also. Sequential function chart, no, they don't count because it's like a flow chart, but they don't have their programming in their own programming. They will be using the other three of them. Maybe if I have an example, I can show you.
But very rare people using this function.
No. Very rare for everybody lah. Because SFC famous for Mitsubishi.
Sorry?
Mitsubishi, SFC. I mean, sequential function, the SFC lah they call SFC. It's famous in Mitsubishi.
Mitsubishi.
Okay, but now later I will try to take one program and show you. Or if I can. So let me see my laptop. Okay, okay. Okay. Now you go to latch and latch. Open. Okay, then you do normally open. We do like this. Okay. So normally open the PB1. Then you use the L. L will be under the beta or in the favorite also you have. This one make it LAN 1. No, it's a PB1.
Oh, sorry.
The latch is the LAN 1. Then you go to next line, you put PB2 U LAN 1 unlatch. This one is same like yesterday we do, right? The push button on output. Latch. and unlatch. Okay, the last one only. I mean, this one no need. Okay, this one is a U actually. Right? Unlatch.
Oh,
So you double click. No, the L. Yes. Then you can choose output unlatch. Go down. Yes. OTU. Okay. Alright. This program no need I just do a comparison. So this program is exactly same like this program like yesterday we do. Because yesterday when we this is a normally close, right? Okay. So yesterday when we so the current like this. So when I press the flow go like this, energize the lamp, when lamp energize, this one energize and like this. If I remove the push button, the lamp will be still on left, right? So you see this ladder logic, right, is similar like wiring diagram, like a single line diagram. Right? So here is the 24 volt, here is the 0 volt. Okay. So for coil, I must have a continuous signal, then only the coil can be continuously on. So that's why we latching. So this one same. This one is when I on this and I on the lamp. If I off this, the lamp will be still on because it's a latch. It will keep the data. So means inside here is something like this.
Then this is the function of match.
Yes. L. Okay. So if I want to off the lamp, I need to unlatch it. So when PB on, I energize this, then I unlatch.
Ready.
Yes. So I will cut off.
Ah,
So this is called set reset in other PLCs. Set data, reset data. But in element they call latch the data, unlatch data. So to on a lamp, like for example, you can use this method also can, or this method also can. Both the method you can try. Oh, your laptop is 21, right? Okay, first thing, wait. Okay, yeah. You try to pick and pick, is it? No, cannot pick. Oh, this one. Okay. Yes. What is it? Okay. Yeah. So because just now we tried to download, what issues?
Field.
Field. No part.
No.
Yes, correct. Okay. So, okay. So what you do, you go to communication, to active. Okay. Then, in your system, because you see this laptop right yesterday, got so many communications.
Yeah.
Different PLC, right? So you need to choose which one correctly. Yeah? So which one? Not the you say internet. Because you connected internet. Okay, you open until you see the processor. Okay, wait, very simple. Okay, you open already, right? You click here. Okay, you see cannot nothing, right? Then you open again. You click compact logic, still cannot. Okay, next one. So until you see this one.
Process.
Yes. So that's why I said so in the processor only you can communicate. Sometimes what internet module you can communicate. Sometimes on the processor you can communicate.
So we go to
Okay, you want to go online or download?
I want to go online.
Okay. When you go online, right, it won't allow you to go online. Because you know why? Your project and the project inside PLC is two different things. So of course cannot go online.
Okay.
So you only able to download.
Download.
Yes.
That's why you run this message, right?
Yes. You can see here. The open project does not match the project in the controller.
Usually, let's say we have no program inside this one.
No program is okay.
No. What means maybe this is for the other projects.
Okay.
Then the project stop already.
Okay.
We use the device on
Okay.
another projects. Okay. So which means that this PLC inside already contain the whole project.
Yes, of course.
Yeah. So what's the method that we want to release it?
No need to use this.
No need.
Right. Whenever you download, automatically we override, wipe off everything.
But usually, if let's say we want to pass to someone, we want to hardware to someone,
Adhere to someone.
then we don't want them to have the program.
Then you just create one simple logic and download it.
The default one.
Easier way lah.
Yeah.
Easy, but can reset, I think. Can reset.
You know what I mean, right? Sometimes we don't want
Of course.
people to check our.
Yes, of course. So just can just download a simple one.
A simple one and
Download it.
nothing one lah. Just include override it.
Yes.
Okay.
But we can reset the controllers. Okay.
Can.
Can. I'll show you.
Okay.
The key switch is run position. Okay, now. Okay, wait. Yes.
Okay, coming. I just have questions. Why did this? I don't need to move this one. I'm supposed to trigger HPLCs like that. If I press here, number 5 output will input will trigger. If I go to the controller tag, yeah, I will set it right.
one, data file. Okay, go back to your program. Then press switch 5 also on. Okay. Okay, something. Wait, I check. You go to lagi join the solar. Yours, I know what is the problem. Okay, whatever you press, number switch number 5 also is on, right?
Yeah.
Okay.
Even though I have audio moved out, so it's not a wiring issue.
No, it's not a wiring issue. Because if you press this one and on this one means it's a wiring issue. But if you press all this on this means it's not a wiring issue. Okay. You go offline first. Go to control tab. So addressing is look like that. No issue in addressing, right?
Yeah.
Okay. You go to local one, yeah. Okay. Off. Close. Okay. Go back to the latch and latch. Switch 3. You click here. Okay, you choose from here, right? Yeah. Okay, what we do one thing. That is okay. Just now yours also cannot turn on the lamp, right?
Yeah.
You know why? Because we create a subroutine, right? So you go to main. In the main, we need to add this routine. Okay? Okay. So you add one run. Okay. So the instruction name is called jump to subroutine, like JSR. Okay? It's under program control. You go back. JSR. Yeah. Can you see? No, I suspect that is the problem lah. We solve that issue and see first. Okay. Under the program control. Can you see program control? JSR. Yes. This is the block. Okay. But I just want to use this one only. Routine name. The input parameter, output parameter I don't want to use. So you right click the input parameter. No, you click on the read. Yes, right click there. Okay. Remove instruction parameter. Yes. The input parameter also remove. Okay. So normally I just need like this only. Okay. But there's a shortcut to do this. Normally I prefer that shortcut lah. That is, okay, you delete this one. Delete the JSR, now mind. Delete instruction. Delete instruction. Okay. So normally after you add, right, you double click here, it will come up like this. Okay. You just key in here JSR. Enter. Okay, so it come up like this. Okay. Now here you choose the latch and latch. Okay. So this one no need. Okay. So your online is it? Okay, online means what you do? You click here. Yes. Hey, sorry. You put to remote. Always put to remote. Why you put run? So you finalize because you did online. Yes. Yes. Okay. Now you go to your program and you test. Now you test. Still same. I know, you already removed the inputs. Then why? Ada unless kan? Boleh?
Always need to use this way.
Okay, you try to remove. You remove the whole line. Okay. So switch two, right? Sorry. Okay. But you use this one, you unlatch all this.
Use the punishment.
Okay. Now one you delete that. Eh, now number 5 on it. You put you unless you click here. Then you add unless under the big. Yeah. 1, 2, 3, 4. You put 4. In one line.
1, 2, 3, 4.
For all that case. Ini letak L1. L1. Okay. Okay, then L5 take up. You copy L1, you paste in line. Just paste. Okay, change to L2. And L3 and L4. Why you call? Coffee. This means 1, 2, 3, 4, you on the lamp, this one to off the lamps. Okay, you download this. So the switch 5 I take out already. You see, this is what will happen when you download. Everything you cut off. Now on this 1, 2, 3, 4. This one to cut off lah. Okay. See, no, still on. Number 5 is still on. Because this one, you see, is number 5, right? You put 5, right?
You
go
are
to the power supply.
right.
Number 5. So this one,
Terbalik lah.
salah. It's supposed to be the other part. Other part. Sebelah dia. So I also wondered what happened.
So that one is possibly yes. So what happened dekat DCCOM tak ada input right? So when you input, so nombor 5 dah ada input. So dia it become number 5 the common. Okay, then input 5 mana?
I also want to add. Sometimes this is not happening.
Yeah.
Sometimes our focus need once you muscle memory.
Yeah.
Then you have to trace the jobs.
Very different, no?
Yeah.
Number 5, yes. Then you type this here. So this good. Okay. Now. Okay, good. So that just now the problem is now what I have. Okay, now you see the latch unlatch is something similar to this one. Right? Okay. So means if you want to on a boolean, okay, if you want to on a boolean, you can use a coil, normal output coil, but LMW they call output energized OTE. Okay, but for me, normal term we call as a coil, output coil. Okay, so you can use a output coil or latch unlatch. So it's depend on how you want to play with the program. So yesterday I told you right, I do a program for students, the 8 type of program, right? So one program I do all coil,
Okay.
all the output is coil. One program I use all latch and unlatch. Then another program is half is latch unlatch, half is coil.
Okay.
That's how I play with the differences, because you can use latch unlatch also can, coil also can.
There is another method.
Another method lah. Means, but the thing is like this. Any logic you can use coil, but not latch and latch.
Yeah. Because
Easy.
they are straightforward, right?
Yeah, this one is very simple. For example, okay, let's say I have a sensor, and sensor is on, the lamp on, for example, like. So when sensor is on, lamp on. When sensor off, lamp on. So I can do like this program.
Yeah.
For that, I can use latch and latch. Because only one button,
Yeah.
on and off. But for this one, I need two. For to latch one signal, to unlatch one signal.
Depend on your requirement.
Yes. Another thing for me, but mostly they use this one. You know why? Because you see, to on the lamp, to off the lamp is the same line. Only one line. So easy to troubleshoot, easy to understand. But here, I need two separate lines. Okay. So sometimes this line will go to some below there.
Yeah.
So it's difficult to download. So that's why when you see in your program, mostly they use coil.
If let's say, because the program is keep on improving, right? So let's say the like this kind of issue. Right. So maybe you want now you do after 1 year the run is below it. You still can push up the run.
Yeah.
You want the runs whatever you latest one.
Yeah.
Together.
Yes, together.
So
But not necessarily, because normally it's because it's to on and to off right now. But you need to, but the position also is matter. But scanning is very fast, you know. Okay. How the PLC work? The PLC will scan left to right, top to bottom. That's how the PLC works. Okay. So sometimes some program will go down, then one is repeat back right. Sometimes we'll have cannot work.
because of the position. Yes, the gap and also the positioning. And normally in my project, when I use the latch, or if other PLC call set reset, if I do one job, one process is done, so I will latch a memory. So that to indicate okay, the process is done. Then I can use that system, that memory for the next process, something like that.
So given the case, right, if let's say the maximum huge program for the PLC to run from top to bottom is roughly the maximum time.
Maximum time, oh, very fast because
Few milliseconds.
of course in milliseconds lah. So depend on the PLC side. But this one I'm not eliminated. That's why I never go search that one.
Because
Siemens I
usually
know.
the program is very
Yeah, Siemens. Okay, because Siemens I know because Siemens I do a lot of research on. So Siemens they call to scan this one they call one instruction. Okay.
one line maybe.
Not online. It will be like instruction per instructions.
Okay.
That's how the PLC goes. Okay. So in one instruction for the 1500, okay, which is similar to the control logic side, will take 1 nanosecond.
No.
Yes.
So I think if let's say it's so fast, then it's not an issue.
Not an issue. That's why I say that's why not an issue. But it's something like this. Okay, how later when you do programming, I can show you that. Okay, because sometimes the sequence ends here, but the output you use below that, it won't turn on. Okay, can you?
Can
Good.
I do something different?
Yeah. Okay. Yeah.
On. If I unlatch, it's like on the top.
You just play with the logic.
Yeah.
Okay. You go for a break. Okay. Alright. You go for a break. Then after the break, you come and see some other functions. So far, yesterday we see the timer, right? Okay. Now we open, now we close quiet, latch. Yesterday we see the timer. Then later we come and see the OSR, or we call it as a one shot. Okay. Then we try to do one project. So this project, because I want you to familiar with the software. Because I think you are familiar with the downloading, uploading, right? Okay. So you can be familiar with the software and tagging. And we do project means you need to use a logical like this. You can logic, try, download, okay, do online editing, test first. Okay. Go for break.
So just now, every time, if let's say we start new projects, we need to go to communication again, right?
Yes, of course, because you know why? Every time you take a new project, this place will be empty. Okay, this place will be empty, so that's why. Okay, but then also, oh, you all have to see. Okay,
This one.
okay. So, but now I already have the path, right?
Yeah.
When you create a new project, it will follow the path. It will follow the path. Because just now why you don't have? Because we already yesterday we already closed the RS logic. We opened a new RS logic. So that's why it's empty. But I already opened the RS logic, I already have a path. Now if I create a new one, I will follow this path.
I see.
So it means if you first time you open RS logic, it will be empty lah.
It's under the RAM
Yes.
memory.
Which one? Yeah. Then I need to go and search lah. Go and give.
But then if let's say that the whole project file, I don't need to do this, right? Because the path will be there.
Old project, yeah. If you open up a project file, the path is already there.
If you go to connect another one,
Of course lah.
Yeah, so
Still,
you need to
I
connect
need to know.
that.
So always better to
Just
check the double yes, like he said, double check your the part.
Okay.
Okay. Actually, when the more you use the software, then you will like the software. Actually, RS Logic is not bad. Okay, of course, compared to TI Portal, I like TI Portal lah. But RS Logic for me is like, compared to TI Portal, is easier. RS Logic actually.
I
Easier.
think both also
Both is great, of course. But for me, TI Portal, because it's more structured, that is what I like about the software. More structured, but heavy, but more structured. Everything is one window.
comprehensive, right?
That's the best lah. Because of that, the software is heavy. Because everything is this one, right? That's why software too heavy.
Because from different people create that. Why is US
You know
US
lah,
minded?
it's German engineering house.
The way of thinking is different.
Yeah, because German engineering, you know, lah, for small car also they put everything. That's why for this one small industry also, anything can do. That's the thing.
So what is it now? Tier portal can cover everything. Is it?
Yeah,
Or you
all
still
the-
need the step 7. You still need the step 7.
Okay, it's depends. Okay, it's like example lah. Actually, tier portal also ada step 7 lah. It's depend on okay your 300 in your machine is using Semantic Manager. The project inside using step 7 Semantic Manager, then you need this software.
The step 7.
Step 7 Semantic Manager. If let's say inside there is already a TI portal, then no need.
Depends on the project.
Yes, depend on project file inside the PLC. Because in your case, you mostly maintain. If you do new projects, then you don't need Semantic. You just go to TI. Longest for 1% lah.
For 1%.
Normally because I do 5 days or 3 days. Sometimes I do the bank. Because sometimes they want like 2 PLC, make it into 8 days.
This one is, you will see, sometimes like at ground, right? Okay, ground. Yes.
That is round. That is round.
Oh, this one. What is it?
No, this one is a round actually.
Oh, okay.
Normally open is here.
All this is ground.
Yes.
Oh, this one direct, ground, you can add from this one. So-
Yeah, so it's okay. You right click also.
Oh, but now why cannot download?
you already downloaded.
But then I need something.
Yeah, you add something. That's why you add online. Right. Then once you add something, you finalize. Right. Means during online, you add some program and you already finalize. So the program is already transferred to your PLC.
Even without download. I don't
Yes.
need to press download.
You don't need to press down because you do online edit. Just now.
Okay. If let's say this one is not green, this means that it's finalizing.
No, yes, correct.
I is which means other
And
I is again.
E means error lah.
E is error.
E is error.
E is error. I is again.
I is in edit.
So beside that, stay like other.
So there's another one called R lah. R is the one which is in the PLC. Because
this one,
if you double click this one, anything like this, double click, become R, right? R means which is in the PLC now, right now. The I is the one I want to edit. Now,
yeah, this one, so how I change this to
okay, now this one, I don't want to change anything, right? Okay, just cancel it. Not cancel it. Yeah. Wait. Because you can edit all this also. Then, no, it's kind of, or you undo lah.
this one is stay under active program.
Yeah,
Let's say
that's first also can. What do you want to do?
I want to delete instruction.
Delete means, okay, first you need to make it edit first. Then only can delete. Let's see.
even after we want to test, this one another account is for 1 minute.
Test.
Is it we need it or we direct finalize?
Direct finance. Unless you want to test whether the logic I create is okay or not. Or correct.
Just now another button that we tick it.
That one is the accept pending run.
Okay.
That one is to accept the run. Then this is the test. This one is finalized. Finalized is the one totally sent to the PLC. Yes.
So this is the test.
Test, yes.
Okay, this one just accept the run.
Accept the run. So if there's any error, it will show you the error. Okay, for example, you add a normally close. Just add normally close or normally open anything. Or because I need to start editing. Okay, you double click again. So because just now I already accept already. So I cannot edit anymore. Okay. So now can you see become 3 greater 3 lah?
So becomes up and down.
Yes. This one now running inside the PLC. This is just now I already accepted. And now another edit. Yes, okay. Okay, now okay, why the accept? Okay. You click sentence normally close or normally open. Just add only. So you don't put any address first. Okay. Now you try to accept.
Why not now become E?
Error because it's not complete.
Oh, it's error.
Error. But let's say you forget about the error, you click accept. Okay, yes. So it will show the error.
Okay.
But when you accept, so when there's no error, it will accept your
The whole run.
yes.
Then only you perform the test.
Then you can perform test or finalize. But you close. But let's say you remove this one. So from here also I know already whether it's an error or not error, right?
Yeah.
Then I no need to test again, directly finalize also.
Okay.
Okay. But no problem. Even got error when you finalize, it still will tell you okay, it's error.
It not allow me to do that.
Yes, well.
Okay.
Okay, good. Okay. Now, okay, so this one okay means and then you finalize. Okay. Now, go offline. Okay, so maybe one of the switch I remove here because I want to show something. Okay. Like this, right? You can do because you see that one latch and switch also on latch, right? Right. Okay. So means here also on, here also on, right? Means I on at 2 places. Okay. So we can do like this, but this is not a good programming.
Yeah, yes.
The good programming is so who on LAN 1? PB1 and also the switch one, right? Right.
Yes.
That is your flow. Right, that is your flow lah, right? The process. So what you can do, if the switch 2, right, you can add below here. So means only one out, one latch.
So how can we do like we want to tekan and lepas, like you're on the line, once you release we off the line.
Then you need to use normal coil.
Normal coil, huh?
Yes.
Oh. So if you're using latch, you don't have to put normally open under the PB1, right?
What is it?
Like a normally open L1.
normally open L1.
Like the first project we do.
Oh, that's yes, can I do?
You will lock that light on.
Yes.
Yeah.
Okay. So you see, when you on do it, but it didn't give you any error, right? No, still can work, right? Means the PLC can accept. But if you ask me, it's not a good programming method. Because when you do manufacturing, right, we call it as a good manufacturing practice, GMP, right? So in PLC also we got GPP, good programming practice.
So if like my one, is there any more simple way to do that?
Yours,
Is it
sure.
like the unlatched, like the this unlatched thing?
Wait, sorry, I put in Monday so many emails.
This one. Can I do like this also?
Okay, what you wanted to do? So when
We turn up L1.
L1,
Yeah, I'm online. Sorry.
online first, okay.
Okay, turn on L1, L2, L3, L4, L5.
Okay.
Once I turn on switch 3, everything will be unlatched, and the red color will and the L6 will turn on.
Okay. Then any one of these is on, I will unlatch the
L6.
L6 lah.
Yeah.
But this is the correct method.
No simple method.
No simple method. Maybe you don't need to do it one by one lah, like this.
Intermittent.
You don't need to what unless like this lah, all in one by one. You can put in one line, so you can put all the inputs then.
What?
You can do this. So you want to unlatch the lamp 6 and PB1 is on, PB2 is on, PB3 is on, something like this, right?
Yeah.
So we need to do something like this.
Yeah.
Oh, so no need to put in each line.
Oh.
When you put in each line, it's like confusing. That is, when PB1 is on, I unlatch the lamp 6 and lamp 1. So if you put like this, so here the switch 1. So this one, you know what? If you see this condition, we call it as a off. I press the PB1 or PB2 or PB3 or switch 1 or switch 3.
You understand?
Switch 1. So you unlatch this one. So it becomes like in one round. So if I see, I can easily understand.
So you can use like the concept of OR gate and
Yes,
gate,
of course.
put it here.
Yes.
Oh.
Then if you want to do like this, okay, this also can do lah. Unless. But if you ask me, but this one will make the line be in one line, not single line. Okay. But if you ask me, I prefer more on like this. Switch 3. I unlatch. But this one become longer lah. So lamp 1, lamp 2, lamp 3, lamp 4, lamp 5. Unlatch. This also can. Then you want to latch number 6, right? Maybe latch number 6 maybe on the first one or the last also can, no problem. Not much different. But the logic become bigger lah when you see. That's how you do the program. On your case, but this also can. But if you ask me, this one is not like this will be confusing to some people to what to understand. If you put like this, it will be easy to understand. Okay. Now, but like this also can, no problem. It's just based on understanding. But in your program, okay. So I want the switch to also on all the lamps, right? Okay. Okay. Now, lamp 1 unlatch. Okay. 2. So I write it down. Can I erase it down? So then you put PP3 to latch the lamp 2, switch 1 to unlatch lamp 2, right? Then your switch 2 is you want to on all the lamps. Okay. But lamp 1, lamp 2 is already on here.
I just want to test.
I know. That's okay, but we can do the same thing. Okay, I just want to simplify your logic. Okay. So when switch 2 is on, you want to on all the lamps. Okay. But lamp 1 and lamp 2 I already on here. So what I do, the switch 2 I put it here. Switch 2 here also, the switch 2. Okay. Switch 2. So here I don't disturb the lamp 1, lamp 2. So here I want to latch lamp. But for switch, right, actually I don't need to latch. But never mind. But you got to do latch. Because why? Because switch 2 I latch, switch 3 I unlatch. So then okay, it's okay. So this one is lamp 3, lamp 4, lamp 5 and lamp 6. So I don't need to put lamp 1 and 2 here. Okay, if I put no problem, it still can go. But if I do another one, it will cause you some problem. Okay, I'll tell you what is the problem. So when switch 3, I want to unlatch 2, 3, 4, 5. Okay. Switch 3, unlatch lamp 2. Unlatch lamp 2 is already here. Right? Okay. But I unlatch lamp 2 here again is no problem. Okay, 2 times I use unlatch, no issue. But latching, try to use only 1 time.
Okay.
Okay, I will tell you why. Then I unlatch all that, right? Unlatch all the switches. So lamp 3, lamp 4, lamp 5, lamp 6. But for lamp 2, you can do like this, or you can take the switch 3 and put it down here also. So you have 2 options for this one. Okay? So you can do this. This is okay. PLC still going to run how you program it. But if someone want to troubleshoot, there will be a problem. So now, unless no issue, because normally when you troubleshoot, right? Why you troubleshoot? What is the problem normally? Because one of the output is not on most of the time. Right? Sometimes, okay, sometimes one of the output is continuously running, is not stopping. That one also can be a problem. But most case is not turning on. So when you open up your program, when you use latch, unlatch, or even a coil, so mostly you go and look for the latch. Why cannot latch? Why the lamp 1 is not working? So according to this one, PB1 is on or switch 2. So only these 2 controlling the lamp 1 on lamp. So if only one place lamp 1, easy for me.
Okay.
If the latch, right, I put it here, then I put another place also. Now I need to see 2 rungs.
Okay.
So sometimes it will be difficult for me to troubleshoot. Because sometimes you need to do sometimes no choice, you have to do some programming. Because It's not because it still can work. It's not error,
Yeah.
right? It didn't give you error. It didn't give you duplicate, but it will give you a warning lah. A duplicate output because you use 2 times. Okay.
But for Brad, we know that if you can, we promise.
Yeah.
The error.
Error. Okay. Go to Logix. Verify. Go to Logix. Verify. Routine. Okay, but no error come out. Okay, go to view. Errors. Okay, didn't give you one. Okay. Duplicate output. This one what? This is yours. Oh. No, normally latch and latch also. Oh, sorry, that one is in Omron. Routine. Yes. Go to Logix. Verify. Routine. This one is ready. Go to view. Error. Because there's no error there. This one. Because it still can work. Right. Duplicate output, sorry. My mistake. Duplicate output in Omron, it shows duplicate output. If I can use 2 times. Okay. In Siemens, yeah, no message. Yeah. In Mitsubishi also same. Mitsubishi give you, it won't show in the warning. When you add another coil, right, I straight away show duplicate. Okay. Now, what I want to show you is a different thing. So this one push button. So I want to latch and latch, right? Okay, this is a switch, correct? It means I want to on the lamp. When I want to off the lamp. So for in that case, I don't need to latch and latch. Correct? Now what you do? You delete this line. Okay, you delete this line. This one I don't want. You delete. When you online, you delete like whatever. Delete. Okay, it becomes the D. So when you finalize, then only it will delete it. When you do online and
Okay.
finalize. Yes. Now the switch to how I want to do is when I on, all on, when I off, all off. So in that case, I only all latch, right? I just use normal output enough. You double click here. Double click. Change all these to normal output. Double click. Choose OTE output and adjust. Yeah. Yes. Okay. Change all, then you finalize.
Okay.
Okay. But give you warning, right?
Yeah.
The warning is because here you use latch, here you use normal coil. Okay. But it's a warning only, right? Because it shows that I use these 3 places lah. These 2 lah, right? So it's warning still can run. Okay. You download. Okay. Now you turn switch 2 on, you on switch 2. Okay, on lamp is on, you off. You press the PB one. You on here. It's supposed to on, right? But it's didn't on. Why? It's supposed to latch one. Alright. Okay. Nothing, no problem in the hardware. It's actually the problem with the program.
Because there's a flash on.
No,
Yeah.
no, because I didn't press the PB2 one.
Okay.
Because here I use latch, here I use coil.
Uh-huh.
So how it works? Okay. We just focus on the lab one only lah, okay? So PB1 latch network. It's a latch, right? Supposed to, when you press must be always on.
Yeah.
Correct. Then when switch 2 is on, I using a coil for lamp 1. Okay? Okay. We focus on only the lamp 1. Others all can work. Okay. Now you turn on the switch. If you turn on the switch, the lamp can turn on. Right? Correct. No issue. Okay, good. But when you press the PB, the lamp cannot on. You press and hold, still cannot, right? Okay, I will tell you why. Okay, how it works. Okay, when I press this, when I on this, okay, I connect. Actually, I on the lamp. Blinking. Blinking, yes, correct. Yes. Actually, I on the lamp. Okay? But how my PLC work? PLC will scan program like this, one by one. Okay, when my PLC scan here, the lamp is energized. Okay, but I still pressing up. When my PLC goes here, okay, nothing is doing so. When my PLC goes here, the switch is not on. So what happened? So it won't turn on the coil. Right. So means what happened is here when you press here, according to the logic, here I on, here I off. That's why when you press and hold, it blinking, but not continuously blink. Once suddenly blink, right? Because scanning. So if you see the theory, here I on, here I off. But since the scanning is very fast, so physically we cannot see it's on. Everybody at least okay, you can see the blinking. Some other PLC you cannot see. Always off. So that's why when I use one is coil, because the function of the coil and function of the latch is the same thing to energize. Right? So that's why I give you warning. Means it's no error. Unless you do a latching. If I do like this, then the program can go.
Oh.
Why? When you press this one, I on here, right? I will on here. And I latch. So you pull on here. So you pull, so you energize this. So when my PLC, so means very simple. When I press here, the left one, it will on here. So when my PLC come and scan here, it will see, okay, this one is already on. So it will continue on. So that's the reason. So that's why I say, whenever there's one output you want to on, so I have switch to, so I better use switch to here. So just now you put latch, you didn't see the problem. But the moment you change to coil, then you see the problem. But if you do like this, no problem. But if I do like this, let's say I don't have this. So like I said, the troubleshooting will be difficult. You want troubleshoot because you will find, okay, which one is the problem later. Because like this is easier. Like same. So many interlocks are really some like this, right? then we don't know what is the issue. Then some expert. So we don't know where is the problem. So better to use all in one. Or if so many, right, so many interlocks. So what I will do, I will do like this. Let's say now I have one output. Okay, and let's say example, okay. When I start, I have a motor on. I use normal coil, okay. Then when I have a sensor 1, click on. And sensor 2 must be off. If sensor 3 or sensor 4, one of these is on, I need to on the motor. Something. Then I have so many things. Okay, then there's another place I have something else. Okay, after the timer done, I need to on the motor again, for example. Then I latch it. So when sensor 5 is on, then I have sensor 6, then timer 2 done. So something like this. Okay. So when I add this, so what I will think, I will try to think or put all this into one run. Right, easier for you to troubleshoot. But if I do like this program, still can go also. Okay. But if I do, okay, I need to add like this. T1 done, because T1 to on, right? Then S5 to cut off, then I need to put somewhere in S5. Then S6 or T, sorry, so I need to add, which is 2 bit, right? Still, but of course, normal programming also like this only. Okay. So too many interlocks. So when I do program, which is smaller systems, when I face like this, what I do? I don't add. Okay. I change this one into a memory. Okay. Memory means like internal tag. So that is okay. Motor on 1. Okay. This one motor on 2. So now this is to a memory and not a physical output. Then I click another line. Motor on 1 or motor on 2 is on. I want the motor. So I do something like this. So this is the like memory lah, right? So when I troubleshoot, let's say the motor is not working. When I go to this line, from this line, I know already which one is not on, not working.
So can you go which one?
So I just go to that directly. Like this also. So it depend on, but it's depend on how you want to program. It depend on personal the programmer. Which one he prefer, for him is easier for him. Okay. Okay. Right.
Which means that don't duplicate
Duplicate
output command.
Yes, of course.
Right? You play around with input.
Input, yes, of course. Play in the interlocks, yes. Okay. no space. Lepas tu right click timer 1. Kena define, yes. Baru boleh tambah dia. Okay. Good.
This one, so let's say I assign push button to cut. But then the light still.
Okay, why? Because if you are using latch, if you're using latching, you need to unlatch it. If you want to off it like this, right? You latch it. So if you want to off, you will need to unlatch. Because I see you do the holding, right? It means if I want to put normally close to cut off, this one must be a normal output, not latch output.
So
Yes.
output results.
Yes, correct. Go to the plate. Okay, you have the plate. You can do one project.
Yeah, this one is how.
You put a timer name. No, timer. Yes, the one must be a name. A tag. Showing a timer one. Enter. Right click the timer one. Okay, new. Yes. So you must create the tag first. You need to define the tag. So what happens is when you on switch to okay, think of because you use enable, you use this right, switch to and on, first directly on the timer. But if you want to on switch to, then after 10 seconds only I want to on the lamp, right? Then you need to use the time.
Trigger gas after counting only.
On the lamp. So now because if I do that, this is running on the enable, right? So this direct.
Or I need to do the key off, right? If it was
No, T off is when I turn on the output directly on and turn on. What you want to do? How you want to do? When you want to switch to after the timer, you want to on the lamp or what?
or I think the things I need to shift out to the main round.
No. You tell me what you want to like, give me idea.
Because I share all the input, right?
Okay.
Basically, I just
No, why you want to add this time?
I just want to stand on for 10 seconds instead of because I'm using this one here on.
Okay.
So you may say on this one as well, right? This one is triggering.
Yes.
Even after finish, it's still on.
Okay.
Yeah, I just want 10 seconds. So I think this one I need to shift out here. Right?
No. Okay, again. Because you see I got 3 inputs to control lamp one. Correct. Okay. So you have a push button to on the lamp one. Okay. So that one is okay, right? Okay. Then you have a switch 3 to on the lamp one. Okay. Then you have a switch 2 to on the lamp one. Okay. Now the timer for which one? You want for switch 3, switch 2 or for the lamp? So every time the lamp on, after 10 seconds, the lamp must be off.
I want the switch to
Okay, so whenever the switch 2 is pressed,
There's the lamp is
Lamp is run for 10
10
seconds,
seconds.
then I off. Okay.
It's different from the push button one and the switch screen.
Okay, so because push button one, switch 3 is like always on
Until
until I press the stop. Okay, that is the question I wanted. Okay. Okay, you cancel the edit. Test. Cancel. So this is the one. The switch 2 is not there, right? Okay. So what I do, you add one rung below. You add one rung below. Shake slowly. And undo. You add one rung below. Just add one. Okay. Now you add a switch 2 first. Normally open. Okay. Switch 2. Then you on the timer. TON. Put timer here. Just now you already created the name, right? You can use back the same name. Click time. TI. It's not really okay. It's already there. Just use that. So 10 seconds. So, no, the accumulator not in. Accumulator is empty, leave it empty. So means when I press this, I on the timer here. Okay? Okay. Now, what you want to do is when switch 2 is on, I want to on the lamp for 10 seconds, after that off. Okay. You know a timer, right? Timer, whenever I on this one, for the timer, I have 3 outputs. One is enable, which is always on based on your switch. Timer done is after 10 seconds. There's another one, timer TT. TT is on for the timer, then it will off back. Right? The TT is whenever I turn on and the timer start to count, I will on. Once I reach my set point, the TT will off. So that is when you want to on the motor, right? I mean the lamp. So you it's not done already. Okay. Then you double click here. Add a branch here. Wait, you click here first. No, click here. Okay. If you add this branch right here, this branch like this. Okay. You click at the side. If you add this branch, click here. It's the same thing. It will be the same length. That's the difference, huh? Because sometimes you see your program will be like this. And you want to try, you cannot get. So this is the one. Okay? Put normally open. You put timer1.tt. Okay. Alright. Okay. Accept. You test and see. Test first. No, use test first. You didn't select the test. Okay. Switch to you on. Timer running. You see the TT running, right? Then the lamp is on. Okay. After 10 seconds, this one off already, right? You see, after 10 seconds, the TT off already. Okay. But the lamp is still on. Oh, okay, never mind. Don't use TT. Okay, I will, because we can learn a new thing here. Okay. What you do, you cancel the test. Don't use TT, use the switch 2 here. Cancel accepted. Yeah, cancel accepted. Okay. Again. No, wait. Undo first. You should finalize. You add one rung, the timer. You can see the timer gone already. Okay, you add the timer. Okay, you add one rung. You put the switch 2 on the timer. We learn for one duty. Okay, number 1. Okay, double click. Just choose this double. Okay, no, double click. Hit the arrow. Okay, just timer 1, right? Just double click. Okay, put 10 seconds. Okay, enter. Okay. Accept. Finalize. So we already create a timer. Now is when switch to on, time is on. After the timer, I want to off. Right? Okay. You add here. Double click here. Okay, you add a branch. You put switch to. That's now one. Okay. Can. Re-addition. Okay. Yes. It's the same thing only. Okay. Put here. Now we open switch. Excuse. Okay. So when switch to on, you want to on the lamp, right? At the same time, when switch to on, we finalize first. Set and we finalize. When I see you stop. You on switch to. So when switch to on, lamp on. When switch to on, timer on. Then after 10 seconds, the timer will time. Okay. Right. So now what I do, I use the time to cut off here. So you double click here. Put normally close here. Beside the TV2. Normally close. Yeah. After the peak go in front of the camera. Yes. Because I want to off the lamp after the timer 1 done. So you put timer 1 done here. Okay. Accept. You want to test, you can test or finalize. We test, put the test in the test mode. Okay. Switch to on. Then it's on, timer running. After 10 seconds, it's going to be off. Cut off. Because I need to use the time.
Just now you mentioned about done and versus TT, right?
Yeah. TT is when timer is counting, right? That time the TT is on. Timer done is after the timer finish counting.
That's why we normally close.
That's why we put normally close after the time.
If you want to put TT, then we put normally open.
TT but cannot put here down, must put down here. But it will be because I'm using a latching, so I cannot use that method. Unless I only use switch 2 and the lamp, then I can do this. Unless I just use the switch 2, so switch 2, timer, let's say in T1, then I just put T1, so I don't need to latching. In this case, only that is switch 2 is on, timer is counting 10 seconds, then the TT will on until I reach 10 seconds. Then after TT on, the lamp will on, right? So until I reach 10 seconds. After 10 seconds, then the TT will off, the lamp is off. But just now we do because there is a latching.
The whole and the one.
Because it's a holding, right? So, of course, for 10 seconds on, after 10 seconds, it's still be on. Yes. So that's why use T. TT cannot. I didn't see the logic.
But then is it better than the timer, right? We move beside the switch 2.
Besides switch 2?
Yeah.
No.
Why?
Why? Because this one, okay, good question. Because, okay, what I want to do is, I want to cut off the lamp after the timer. Right? So means I need to cut off the latch. So I can put it here, or I can put it for the lamp 1 ESM. Because if I cut this, I'm cutting the latch. But not this, because if I put this one here, the lamp is still will be on using this condition. Because the lamp is on because of the latching here. Right? So if I want to cut off, I need to cut off the whole latching of the lamp 1.
But as you interrupt the command from PB1 and switch 3 as well, right?
No. If I put the timer 1 to cut off, no, it won't interrupt because I'm using a normally closed. You press PB, nothing. Because your timer is not running.
Now PB activated, right? PB1 activated.
Yeah, PB activated, your lamp is on.
Activated. At the same time, if let's say I switch to also activated, then I do it counting.
Yes.
Yeah.
Switch to activated, yes, of course, it will do the counting. Do the counting after the timer, it will have.
It depends on what the scenario, right?
Yes, it's depend on the situation, how you want to control them, how you want to play. So depend on the flow, the flow. Anyway, you just play. Let's say still cannot use this. Say, let's see, if PB on and the switch is on, then the timer cannot run. For example, okay, because now just now you on using the PB, right? And so the switch is on. So because the lamp is on because of the PB, so I cannot cut off. For example, if the lamp is on only because of the switch, then only after 10 seconds you can cut off. In that case, I need to create a program more.
If let's say situations that are because right now, if let's say I activate the PB1,
Cannot.
you
Yeah, the switch is still on. The switch 2 is still on. Because your switch 2 is still on, timer already done, so I cut off.
now let's say I PB1 deactivated, right? So my switch 2 also doing the activated counting. Then you cut the
Lamp.
lamp. In fact, right, the PB1 just now I activated. I don't want the switch 2 to cut it off.
Can also.
You know what I mean?
I know.
I just the PB2 to cut off the PB1 instead of the switch 2 activated. Then by the counting, then cut off.
Yes. So, So you need to put a condition, another condition that is,
Another condition, right?
yes, so
Yeah.
make sure the lamp, so means the switch 2 must be run when the lamp is activated by the switch 2. Correct? If the lamp is activated by the PB or the PB1 or the switch 3, the lamp cannot run. I mean the timer cannot run. So I need to create another logic to do some interlocks. So for that I need to use some memory.
Different way.
Yeah, different, not different way. The same program I need to add more conditions.
Yeah.
Ah.
Because
Because I need to tell my PLC that is the lamp is on by push button. So when the lamp is on by push button,
you cannot cut off it
you cannot cut off
unless
PB2 is on.
Mm.
So it doesn't matter whether the switch 2 is on or off.
So if let's say under the condition during switch 2 activators,
Mm.
no PB1, no switch 3, then you do your job.
Yes.
You will just activate for
10 seconds?
10 seconds.
Yes, yes, correct.
But as if let's say the scenario that's PB1 or switch 3 trigger as well,
Yes.
you don't cut it off.
Yes, correct.
Okay.
And
Then
so what I need to do, okay, good, this one. So now because who cut off the lamp, the timer?
timer and PB.
PB take out lah, the timer, right? Okay. So now you need to tell the timer when to run. So whenever switch 2 is on, you run. If PB activate the lamp or switch 3 activate the lamp, you cannot run the timer. So you need to put some interlock here. But before I put the interlock, I need to create the interlock. So to tell my PLC that is the lamp is on by PB. So I need to create another logic there.
Oh,
Then use the memory as an interlock.
memory.
Yes.
The memory is using the later programs as well.
I mean memory is same, right? I mean your timer is a memory actually. So means whatever you create in the controller tag, right? If you put alias, it's an input output. If you didn't put any alias, it become a memory. That's all. Very straightforward, I show you. You accept first. Accept this setting. Okay. Finalize. Okay. Now, what do? You add one more rung. We do here. Add rung. So we need to add a condition that is okay when the lamp on. Okay. So if the PB, so you put normally open PB1. Okay. You want an output. Then you add here, just put interlock, a new name. No, it's not in your tag. A new name you put interlock. Okay, so you see, interlock is a base, right? It's a base, so it become a memory inside the PLC.
So we have two types.
What is this alias? Alias means you need to alias to your keyboard. Yes. Okay, clear. Okay, you latch it. So this you see there's no local or something. So when you see in your program something like this, it means it's a memory. Okay, you hold it, latch it. Put normally open interlock. Interlock. It's the same way. That's it. Okay. when PB is on, I on this memory. Okay. Then when PB2 is off, of course lah, I off the memory. Same like your lamp, you know. Okay, but this is a physical lamp, it's an internal. Okay. You normally first same, or you copy the PB2, put it here. Copy. Okay. So you can use the, the shortcuts, your shortcuts. The Control C, Control V, all the shortcuts can use also. All PLC are same. Okay. Now, so your switch 3 also must the same condition, right? Switch 3 also.
Yeah, switch 3 and PB.
Okay, then you add switch 3 here, below here. Okay, yes. Put switch 3. Yeah, put switch 3. So what happens if I press the PB or switch 3, I on this memory. Okay, so now I use this memory, put it here. Can you finalize this first? Okay, you can test. You just press the PB one. No, just press the PB one. Okay, you on this memory, right? Okay, you press stop. Okay, you on this memory, yeah. So there's no output linked. Okay. Okay. Now what I do, I use this one to cut off here. So you double click here. Okay, put it here. Yeah. You put normally cannot copy. You put normally close here. Normally close. Normally close. Yes. Then interlock. Okay, finalize. Okay, so now what happens is, okay, you switch to off already. Okay, now when PB is on, I on the lamp, right? Correct. And at the same time, I on the interlock. Correct. Okay, now you switch to already on. You see, your timer won't go. Okay, you off the switch 2, just now switch 2 is still on. Okay, you stop, you press the stop, second one. Okay. Now you only test the switch 2 only. Okay, you on the switch 2. On the switch 2, the timer can run. Okay. So if you only on switch 2, the timer can on. Then after 10 seconds, the lamp will off. So you off the switch 2. Okay. Now you on the PP1. Okay. So when you on, the lamp is on as well, the interlock is on, right? I use it here. And now you on the switch 2, it cannot go and run the timer. So it cannot go and on the timer, so it cannot off unless I press the PB2. Okay, now good. When you press PB2, still the lamp is on, right? And the timer running. Because you already pressed the PB2 already. Because the switch 2 is here on, right? So it's running on the switch 2. Based on the condition, yes. You need the more you put the condition, the more you can add.
This is really good.
Yeah. This is how the logic works.
It's like similar like my one right now, like you open my one.
Oh, yours.
Right now it is light sick, right? I want to press the light cannot.
Yeah.
And then I turn off like 6, then I can turn on.
Yes, because you put the switch as the interlock.
Yeah.
So you means you use a physical switch.
Because
He want to use the push button as a interlock.
Oh, okay.
So what I have to do, because the same concept, yeah, you are correct, because I can use the same concept. Okay. Because I can use the PB1, put it here as an interlock, but it's a push. When I press, it cut off. When I release, it go back to normally close.
Yeah.
So that is the reason from the push button, I create the interlock. If I use switch 3, right? Actually, I switch 3 directly can use it because it's a switch. So it's just need to play around with logic. Yes. How you want to. That's why you need to add the condition first. So you need to tell, okay, when I press this, this one need to be on. When I press this one need to be off. So you need to create all this condition. So you follow the condition, you can create a.
For this switch 2, if let's say switch 2,
Okay.
see, if I on, you start counting. If I off, then you will reset.
Reset, okay.
If let's say I want to change as a trigger point, this is the trigger point.
Trigger point means what?
Which means that the moment the trigger, when you start counting, the colors of my switch.
Okay, then what I have to do, I create the switch, another memory, then that memory runs the timer.
Okay. Because if let's say anything happens like sensor,
I know, that's what I say. Because earlier you tell me switch 2 is on, run the timer. So this is the problem. Now, if the switch 2 is on for a few seconds, but
just one trigger
just
point.
trigger one pulse only. But I still want to run the timer to on.
Yeah.
Then I need to add a memory. Because I need to capture. Because why? Because for timer, I need something is always give the signal to run the timer. So since your sensor is like on and off, so a timer cannot run. So what I do, like same concept, like BB is like on and off. I capture and I latch it, right? Same concept. For sensor 2, when it's on and off, I capture the data, use a memory, then latch it. Yes. Then use that memory to run the timer. Yes.
There's a timer to cut the latch as well.
Yes, that timer will cut off the latch as well as the latch. Because the next time I on, I need to capture again.
Otherwise, nobody will.
Nobody cut off means
Yeah.
nobody cut off means that so it will be timer
Continue.
on.
Continue latching.
Yes, so it will be same similar like your sensor is like always on.
Yeah.
Okay?
So sometimes
Play off us. That is called logic. So logic, of course, you need to play around. The most important thing is you know okay, how to use the software like mainly download online, edit, finalize, cancel the edit, and all that kind of. Okay. Okay. For one go for your break. Okay. Then after the break, we can go. So maybe after the break, just nice for us to do your project. We do a project.
So go for 1 hour. Okay, bro.
Alright, see you later.
Bukan,
Ya, makan lagi eh.
makan sering lah. Maksudnya okey.
Okay.
So we do a project, but before that, we discuss what project we want to do, and we do a project. So whatever just now you've done, right, just save it, so we don't disturb that project. Later we will create a new file, new project. Okay, before that, whenever we want to create a project, we need to have a flow chart. Right? Okay, when we have flow chart, it's easier. Okay, so I like to use like this pillar. Right? I put like these two symbols. This one is the condition, and this is the function, like what I want to do. The function. Okay. So for example, create a simple system. Okay. Then I press start and auto one on. At the same time, I want to on a timer 1 10 seconds. So like the program yesterday we do like, okay. So when the timer 1 is done, auto 1 is off and auto 2 is on. Okay. Then if I press stop, auto 1 and auto 2 off. So this is flow chart. The condition when I press start, I need to run time auto and timer. So when the timer done, timer right will give you an output timer done. So I use that condition. So when the condition is on, auto 1 is off, auto 2 is on. So I play with the condition, okay, what I do. Condition, okay, what I do. So if I want to create a logic, so when I start auto on. So when I start auto, okay. I use a coil, right? Okay. This is a push button. Okay. They won't tell you whether you want to latch or you want to use latch unlatch or you want to do a holding all that. Okay. They just tell you okay on or off. Okay. That's why just now whenever discuss, right, I ask you the concept. Okay. What you want to do? The sensor is on. Okay. You on the output something like that. Then, okay, because I'm using a coil, this is a push button. Because when I start, after the timer only motor 1 will off. So, I latch it. Motor 1, okay. And when I start, motor 1 on time. Then same start button on timer. Okay. Now, start on T1, let's say I give it T1 10 seconds. Now, can start button run the timer or not? Cannot, because this is a push button. When I press, yes, the timer can run, but when I release, the timer will reset. Just now we test, right? Okay. So, what we do? Motor 1. But in your flowchart, they didn't tell you motor 1, right?
Yeah.
But according to the flow, because start and motor 1 on at the same time, so I can use motor. So when I start timer motor run, timer trigger. So timer will give me one output, that is the timer done. So when timer done, motor 1 need to off. Okay. So now I'm using a coil. So if I want to off, T1 done. Right? Right. I want to off, I put it there. I need to cut off. So I can cut off this line, or I can even cut off here also. Okay. Because when I cut off this, I'm cutting off the latching. But if I put here, it will be more clear. Okay. So when timer motor off, then the same timer need to on motor 2. And T1 done, but I use doubling open because I want to energize motor. So this one I need to latch around. Sometimes we don't get idea because this one I know I need to do a latching here because it's a push button. This one sometimes I cannot imagine.
Yeah.
What we do? We download and test this. If motor 2 can on, we leave it. If cannot on, then you need to latch it. Because you know why? Of course, the T1 it become T1 done become like on and off because after the timer, I cut off the motor, so the motor will reset the timer. So your T1 will become like on and off. So I latch it. Done. Then stop motor 1 off. So here is the motor 1, so I stop it. Then the same stop motor 2 off. So you see the sequence how I do the logic. One by one logic. So that's how you can play the logic.
But sometimes we need duplications, crashing.
What's it?
Because we go on line by line, right?
Yeah.
So sometimes we will conflict with the previous instance. Really?
Yeah, of course, depend on how you want, how you play with the interlocks. Of course, sometimes it happens, so need to see. Okay, so like it's not the same thing.
Yeah.
So we try to use that. Just now we try to put that when I press the push button, I don't want the timer to run something like that, right? So in that case, of course, I need to create a memory on that. Okay, then. So this is how from a simple flowchart. From there, I convert into a program. Because when you have a proper flowchart like this, it's like your project, like your logic, right? 60 to 70% is already done. Balance 30% is just to check the looping like this one changing, it's supposed to restart, but I'm using motor 1, right? Latching here, all that.
Can you see the function? So motor 2 will not off manually, auto-ly.
Huh?
Motor 2 will not off by timer, right?
No.
Only
Stop.
motor 1.
Motor 1 is follow the timer.
So motor 2 no timer, right?
Motor 2 timer, motor 2 just a stop light.
Okay.
this kind of project, right? Can we use the previous projects then save the file then modify?
Yeah, of course.
That's how they was doing.
Huh?
That's how they was doing.
Yeah. Okay, so you understand this one, another project, huh? So now I will do one project. Okay, this is not a project, so I'll show you. Okay, can I edit this? Okay, huh? Now what I want to do, because I give you one project because I cannot think about how your ride works. Maybe the next project we do maybe something related to your rides. Okay, so this one normal project lah. So this one is like a tank. This one something similar like the one just now we discussed. Okay, when I start first motor, second motor, right? So it's the same. First output on, after that finish, then second output on, okay, finish, then output on, finish, then fourth output. Okay, it's a tank. Okay, it's a tank for a mixing. Okay, so here I have two valves. Okay, pneumatic valve or something like that. Okay, then pneumatic valve. Mixer. Okay. So here I have one A. This one is one B. Mixer. Okay. So this system you have a start and stop button. Okay. Then this one you have low level and also high level switch. Okay. High level. Okay. So because normally tank will have a level transmitter. What's the level? Right.
Floating.
This is considered like a float switch. Level transmitter means it can give you the levels.
Yeah.
How many minutes? So that is a analog
Yeah.
value. So we haven't learned yet. Okay, we haven't go to the analog yet. So what I do, I use a normal float switch like you say. Okay, normal float switch like. Okay. So we have we call it IO list. Okay, so input and output. Okay. So input we have a start, stop, yeah, and HL, right? So this one, according to your winding, you can use the first two button because it's a push button. For switch, sorry, this is Siemens addressing. So if you can see, this is in 0, 8.1. Okay. And LLHL is the third and fourth switch. So which is in port 0, 1. So number 2 not using. So 3, 4, 3 and 4. So when you do, you follow this. When you do the alliance. Output no issue because it's a lamp, right? Okay. So now we do a project. This project, I want to create an actual system. A simple one, but the actual system. It means now I am using a lamp, right? I can remove the lamp. If I connect actual valve, it's a pump, it can run. That's how I do normally. I normally don't do project like that. Automatically simulate, no. So that's why the low level, high level, of course we don't have an actual tank now. But you have a switch, right? You manually on, manually off. Just now you like, of course, stop is a normal lah, push button. But normally low level, high level, if actual system, we get the free time. But now we don't have actual system, so we manually on. So what we do? First, how we put that on this one? Up 0, up 1, up 2, up 3. I do a simple program first. Okay. So means when I start, your valve A is on, you start to fill, okay? Until I reach the low level. So when I start, your valve A is on, so I start to fill, okay, you just imagine already reached low level. You turn on low level. So when you turn on low level, because I want to stop exactly here. So from the low level until this level, let's say it's the, it will take 10 seconds. So I put 10 second timer. The moment low level on, not the valve A. The moment low level on, 10 seconds. After 10 seconds, your valve A off, your valve B is on. Okay, so your valve B will fill until the high level. Okay. Once I reach the high level, your valve B will off, mixer will run. Mixer run 10 seconds or 15 seconds. The timing is up to you. If you see the timing is too small, you cannot see the sequence, you can increase the timer. But when you do testing, if you feel the timer is too big, want to reduce the timer, you can reduce the timer. Okay. Then means okay, after valve B, mixer will on. When the mixer run for 10 seconds, after that mixer off, pump on. So pump start to drain that, right? So when pump on, your level will increase. So whatever, your high level will off. So you manually off the high level. Okay? Then you wait for a few seconds, okay, just imagine lah, you already go low level. Then you turn off low level. So when I turn off, I still have this range, right? Right. So to clear this range, let's say because the pump is on, let's say I put another 5 seconds. It means when the pump is energized, your high level and low level off already. Run a timer, 5 second timer. After the 5 second only, the pump will off. Okay? So this is the flow. Now I do the flow chart. Start. So for stop button is like all off like emergency stop. Okay, VA on. That's all. When I start, VA on. That's all. So it start to increase. So it will dip. Your level switch will on. So you turn on the level switch. So when you turn on level switch, timer VA. So I put timer VA for this. Okay. For 10 seconds. And after the timer VA is done. So when timer VA done, valve A off, valve B on. So VA off, VB on. So it means this condition, like same as well, like motor 1 off, motor 2 on. Same condition. Okay. So VB on, we go until high level. So when high level is on, VB on, your mixer will on. Okay. So at the same time, I on a timer mixer 10 seconds. Okay. Then once I reach my timer done, your mixer will off and pump on. So when pump on, it means your level will decrease. So high level, low level, off. Timer, pump. 5 seconds. When timer pump done, and your power. Okay, sequence. Okay. Once we finish later, we can try to repeat all that lah. Later we can add some others. Then for stop, all of here one A, one B, all of. Okay, good. So what you do? This project is now one. Okay, you save it. It's up to you. You want to create new project also can, or you save as. Save as. Then you delete all your logic. Then edit your IO lah. Follow this lah, right? Okay, then you can. And one more thing. This one don't do in the main routine. You create a JS a subroutine called. This one you create a subroutine. You put it as a mixer tank. Then in the main routine you call the
Here, how we select the time?
Done. Timer 1 dot. What is that? What is it?
Let me see. I just give you.
Ah,
I do a match.
okay.
So I run.
Okay, okay.
You ready? Yeah. So I don't have to that here when I say when I press run, it just run in.
Okay.
Can also run.
How you want to program it?
This one,
That one enable, you don't use that.
this is how we use it.
Okay. So what do you want to do?
Mouse, another information.
Trigger. Okay. So you can't do like this. You can't use like this. So you can't use like this. So
This is
because the timer after the timer done, right? Remember we can use this. Done. This. No, this one is to energize the timer, to run the timer. Then the timer, if you want to use the timer output, this is how I use the timer's results. But what we do? In project, right? You cannot combine both.
Oh, but that's why I think she's, I don't like for you to use.
I know because your program is, because you see here I use LAM1. Then inside here is not LAM1, right? So when you press it won't go properly.
No, even though the,
Even though in the main routines, yes.
I have to do.
Yes. So this is different. You already name it as a different project, right? Then the next you rename all. You rename all the input output. Start stop. Then easier. If not, will be difficult. Yes. Book the parking coupon today.
Huh?
Today didn't book the parking coupon is under this one. Already put di mana yang kada.
It's not to credit. Well, just now you mentioned that, only one condition that we use is depend.
The memory we created, right? Okay, because you see just now I created the memory, right? Because when I press start, I want to block the timer. Okay? Just now, right? Just now we add a memory, but the name we can put any name lah. Okay, I write down. Can I erase this part? See why just now I create a interlock. Earlier I have a sensor 2 and a timer, right? Okay, a sensor 2 and a timer. Now, in my content on top, I have a push button to on the demo. So this is the program just now you created, right? Then what you said is this is the timer 1. So I put a timer 1 done, and so how it works, your earlier program is when you put push button on, okay, lamp on. So when I press PB2, right, I off the lamp. Okay, when sensor on, I on the lamp, at the same time I on the timer. After the timer I off. Okay, so this is your logic just now. And you tell me that is when TB on and sensor 2 on, and now the sensor 2 cannot cut off using timer because it's on by the PB. Okay, so that is what you are just now you wanted to do. Okay, so that means whenever the push button is pressed, the timer cannot run. Okay, so very simple. What you will think? Okay, if I don't want the timer to run, I need to cut off this logic, right? If I put something to make it open, I mean normally close, right? When it's on, I will open, so the timer can run. So means I can put the PB1. Okay? When I press the PB1, timer can run. But when PB1 is a push button, right? So when I press, of course it can break, but it will close back. So what I did is, from the PB1, I create a memory and I latch it. And I use this memory to put it here. So what happens is, when I press this, the memory will on, so here will break. So if I press the sensor also, the timer cannot run. Okay? So why? Because I want to put something here, but it's a push button. So when it's a push button, I can't. But here I must be like always open. But my push button is pressed and release. So for that, I create a memory. That is put a memory. I just put a name, interlock. Okay. In this case, there's many interlocks you can do. Okay. For example, I just do one thing here. Okay. See here. I start. I think this is how you also do, right? VA and I latch it. Okay. Then when low level on, timer. VA lah, timer VA 10 seconds. After the 10 seconds, VA off. So I put it here, right? Timer TVA done. Okay, this is how you do it the first time. Correct. I start valve A on finish. And low level on a timer. After the timer, so the VA done. Need to off the VA. So this is how I found. Now in this here I can add some interlock. What interlock? Interlock means that the condition. If low level I on, of course the timer will run. Okay, but at what condition I reach the low level? When the VA is still feeling, then only I will reach the VA. Then only I reach the low level. Then only I can start right. So here I can put a we call interlock. The valve A as an interlock here. It means when I press start, valve A is on, so I on here. So then only when low level on, it can run the timer. If I don't have this, still can run. But without the valve A is filling on, if someone go and trigger the low level, I will run the timer. So this is called an interlock. Okay, so it depends how you want it. Interlock means it's like a condition, precondition. This one to on means this condition must be all must be there. Okay, okay. Let's go. Want to go for a break? A break. Go for a break.
But sometimes you want to transfer the flow into the Logix.
Yeah, of course.
Maybe we are. I'm not familiar.
Yeah, but because now only you're trying. So I
I
know.
know to transfer to the Logix.
But you follow just like this now, I do like that method. So means this one all condition, right? Start, no label. So this one all always will be your conditions means either a normally open or normally closed.
Because I'm still not familiar with
The file or timer. Okay.
because timer basically you need memory. Then you use the switch to on the timer function, right? You need a break in the line for the timer counting.
Okay. Timer. Okay. Of course, you need a timer to count. But who on the timer?
You need a switch to
Not necessarily a twist. Depend on the logic here.
all the logics.
Yes, according to in these two, so the low level on the timer.
Timer is just a timer.
So on the
It's
timer,
another function.
Huh?
It just done the counting function.
counting function.
Yeah.
Then after finish, then it's up to you lah how you want to use it. Okay. Then another timer here, right? This timer put on this timer. The high level. This is the condition. This is the function. So same. Here, your high is currently now is high and low both on, both off. Then only the timer right. It's just play. Then just play the condition function. Am I go? Okay, boleh.
Tajam sikit. Cuma tu saya tak.
Hai, dapat so must mix it off baru pump on.
That's what I mean.
One bit off baru high, one bit kan?
Boleh pick up like this lah.
Huh?
Pick up like this.
So, okay,
So,
start. Okay, level level. Okay, level lah. Okay. No, wrong. Supposed to off ni dulu, baru ni on.
Saya nak kira masa dulu.
Okay, bagi dia dulu. Okay, so high level, mixer on lah.
It's on.
Pas mixer pump on.
Yeah.
Okay.
This one you have to turn off.
So ni kena buat. So on, okay, so need to turn off lah.
Oh. Is the one please.
Ini simple pun dah. Kalau komplek dia ambil blunt. Kalau komplek macam right kan.
Itulah.
Why we continue the calculation there is continue running.
If continue running means the input of the timer, right? The condition for the timer it become like off and on. Off and on, that's why.
Every time should be
Yes.
reset.
Reset. Okay, because you have a high level and you put mixer as well, right? So what happened is, so after the timer, I will cut off the mixer, right?
Okay.
When I cut the mixer off here, here also off, correct? When I off, my timer will reset. When my timer reset, this one become normally closed back.
Okay.
But your high level is still running, right? So it's still been on the mixer. So this one don't need here actually.
Because I see the round one.
But this one is different condition. Because this is the previous condition, right? So low level, but if this one different, maybe you can put other. It means the mixer is not suitable here. Maybe you can put others. Later we can think about what you want. So
I
this one
was
is
curious. The valve A is there. Let's say go back. Valve here, but go on.
yes.
Then I trigger my.
Okay, this one wrong. Wait, this one wrong. You know why? Because who on the valve B according to him?
Valve E of timer.
Timer, right? But here you use the VA on the timer. Correct. The VA off on the timer. So it's not suitable. So it's supposed to be your this one. This timer was put in.
Oh, I see.
According to this. So because timer done, you off the VA. So correct. The timer done, you off the VA. The same timer done on VB. So the same timer done was on the VB.
Okay.
That is how we do.
I just take the condition.
Yes.
Okay.
No, let's double click. You can change one. Yes. Timer. I want to check one. Correct. Yes, but normally open lah. Because if the timer not running, this one can you see? Because the VB is on after the timer done. Means it's a normally open. But normally open, normally closed is normal lah. We always confuse.
This
That one need to be practiced here.
Yes.
Exhibit on.
Okay.
You finalize. Set finalize. Yes. So now on A already. Okay. No level on. Start counting. Okay. So your 1A off already, right? 1A off already, but 1B didn't on. Okay? Because your timer done, right? This memory, right? Because I use here also I use right. Here it becomes like on and off. Because the moment timer done, I will cut off the VA, right? So when VA off here, your timer will reset. So your done also will go reset.
Okay.
So the timer done here, it become like on and off.
Okay.
But I want to on the VB, right? So let. That's how we do program.
Using what?
That's with the VB. My output. If I'm doing that, that is called latching lah. If I put something others, it calls or function. Okay. Set finalize. Okay. So we start again, no level on. Okay, because your 1B still cannot run because your mixer is still running, right? Okay, what do you do? Because this one you need to take out that function. Okay, you now go to edit, you take out, edit, and here you add edit here. You add a stop button.
Stop button.
Yeah, because if I stop, I need to off the mixer, right? If I press stop, I need to off the mixer also. So you put for now lah, because it's already latched, right? Okay, now you add here. Normally close.
Only close.
Yeah, because I want to cut off. Stop button. Stop. Can you do right or no? You didn't change the name.
Continue.
Stop. Okay. You finalize. Now you press stop. Okay, we saw. Yeah. Okay. Now you test again. Start. 1A on. Already, yeah. You see, because you see, you can see this one on, right? Okay. Because this one is like an on and off meaning. So that's why we need to latch it. Okay. Now you on high level. With high level on the mixer, you use the mixer to cut off. Okay, can also go down. Then high level on the timer. After the timer, mixer off. Right. So as you see, I remove the mixer from here, so no more repeating. Okay. Now,
So they are like 1, 3, and 4. Is it okay? Let's say I using 2 line.
yeah. Want to use 2 line, want to put in 1 line, also okay, it's up to you.
So basically the high level, it trigger the timer first, right?
Okay, no problem. This is okay, no problem. So high level on the mixer, same high level all the time, okay? Just high level on VB off, okay? So because you use the mixer to off, can also, if or you want to directly put high level here also can.
Okay.
But the best one is put a high level here.
So the commands usually come from the condition.
Yes, correct. Yes. The function is what I'm going to do. On or off. If on, okay, I use a coil. If I want to off, I try to cut off the coil.
So to better understand that, so the main command supposed come from the condition.
Yes, yes.
Correct?
Yes, to on or off must be from the condition.
Giving the main functions.
Yes.
Then the rest is just the executions.
How we get execution.
Executions. If let's say the conditions, in one conditions with multiple
Functions.
functions, then I can separate the multi-line.
Yeah, like this, for example, you finalize first. The high level is the best example. Finalize first. So you see, the high level is the best example. Because here I put a high level on VB need to off. Okay. Where is VB? Here. So how to off? Need to cut off this line, right? There's a latching, right? So need to cut off the latching. So I put a high level here. Normally close. Yeah, opposite that, because when it's on, then only need to cut off. Then same when high level on mixer. So when high level on the mixer. So I put normally open. Then when high level on the timer. So when high level on the timer. So there's one condition. I'm controlling 3 things. So one is to off, another 2 is to on. Okay. Then now the timer mixer done. So a mixer I off already, right? Can you see I put it here to off the mixer. Next, the same mixer I need to on. The same memory need to on the pump. So something similar like this, the timer. Here I cut off, here I used to on the DB, right? Same. I need to on the pump. can know who on the pump. Who on the pump? Your timer mixer done, which is the project timer 2 done, not the high level. So you on the pump, okay, done already. So do you want to latch? I don't think so. Need to latch first, okay? Because it's like always running, right? So actually done already. I'm done on the pump. Okay, now you need to pick another one is when high level, low level, off on a timer. So you see, wait, I'll show you. Here you see when high level on, you run a timer. So you put normally open timer, right? But here they say high level, low level, off. So must be a normally closed. The opposite. High level and low level, yes. Okay. Then another time.
I still need timer.
Yeah, of course, because there's another timer button. That according to here. Because when high level, low level off, I need to run a timer first, 5-second timer. So create a timer.
But usually like this kind of round trip by before, right? Because high level, you need to trigger the timer, right? Is it possible that we join in one line or
Can
is
be.
necessary need to split
I
that?
can join in one line.
How actually program?
Okay. Oh, actually, in this case now, actually this side only to latch because you know what? Because high level always run one.
Yeah.
So since this one is like pass, then only we latch it. Okay.
So I believe it's not.
Yeah. Delete, then you finalize first. Close. The last one, error. You complete the last one first. That one delete. Okay. Then you add a timer for the high level, low level. Yeah.
Because I thought I want to separate the two.
Which one?
How I can add inside the time.
You can add one. Yeah, you click here. No. Click here first. Oh, just one time. Okay. Because this is the condition. There's no output yet. So you can add one. Okay, you put a name first, timer pump. Timer pump, then put a timer. Okay. But finalize first. Okay, go up. Okay. So you see these two lines. You want to make it into one line, right? Okay. So see high level on the mixer, then high level on the timer, T2, and then T2, and I off the mixer, right? Correct, that's how we do, right? Stop here, stop here first. So these two in front, this is same. So I take out the mixer. Then I put this.
Okay.
So come. You click, you will double click. Double click. You click on the high level. And after the high level, you add a branch. You add a branch. Then bring the branch until the end. Until the mixer. Yes. Then take the timer, copy the timer first. Copy structure, okay, you paste here. Okay. Yes. This is the one. Okay, so means you see when high level on, it give you a signal to the mixer at the same time it run the timer. So this one I'm running now. This one, number 5, running. Can delete first. Then finalize. So it becomes one line. Because both the input in front is the same thing. So we can make it one line. So when high level, low level of the timer will run, right? Then the timer done will off the pump. So to off the pump, here you put the timer pump done. Put off the pump. So when the pump on, I need to put it off. On the pump is there, off the pump. Off. So it is normally using. Okay, let's go see. You see, if you follow this is the program. You follow the flowchart, right? But later, like latching all is not there. So slowly one by one we add, okay? One thing already. So when high level on, you cut off the VB on the mixer on the timer. After the timer, you off the mixer, right? Okay, go down. Then the timer will run the pump. Okay. Now you off the high level. course, because going right. When you off the high level, the pump off already. Correct. But it's not supposed to work that way, right? Supposed to low level also off, timer run, then only must off pump. Yeah. So because why? Why the pump is off? Because this memory off already. No, not because of that. You just see, okay. Why the pump is off? Because of this memory off. Timer memory. Okay, this timer is from where? From here, right? Okay, why this timer reset already? Because the high level off already.
Yes.
Okay. So now, so of course we cannot do anything with this one. So what I do in this case, I latch the pump. I latch the pump. Because initially when we test, we see because the high level is always on, the timer also is always on, so the pump is on. So earlier we don't have any issue, right? But the moment we off the high level, the timer reset already. So the pump also reset. So that's why I need to latch the pump. The logic, of course, we need to practice lah. How to play the logic. But most important, you need to know how the timer works. How the timer running, how the timer is working. What? No time is it? For the pump or what? So you can see the figures here 0, 1, 2, 3. Supposed to on this one. And now you on this one, right? Yes. Or you can this is what you're doing now.
This
High level. So, what is it? So, so correct. Okay. So you on high level. So we're supposed to point this one, right? So we can just change here. That's okay. Go down use arguments, no. Already, okay, it cannot be automatic off. Your high level, low level must be off, then only on. So here must you timer. This timer, right? You put automatically on, right? After the pump, no. Must be your high level, low level off, then only the timer must run.
Red light.
So you put normally close, right? Normally close, low level, normally close high level. Similar like this. Okay, low level, high level of timer, right? Then only the timer will reset. Because you put latch and latch, right?
So for stop button, is it okay that I add it in each every line
Yeah, okay.
on the valve A, B,
Yes,
mixer?
so yes.
So I just cut between, right?
Yeah.
Then can go. What is that?
No. Not because of your program. Because you see, now sometimes we take, sometimes not. All the inputs. Yours will be, you continue back, right? They continue balik kan? Because you put the line.
Ya, udah kan.
You put the line.
Pening lah.
Saya tak familiar lah macam
Start stop ni saya tak pakai. Saya buat macam start stop ni. So saya tak paling nak buat banyak-banyak.
yang start dengan stop.
Kalau saya tekan start kat sini, dia automatic run kat sini. Tapi kalau tak run,
Bila command run.
you kena bagi tahu lah start stop tu macam ni. Start stop tu saya buat sebagai run. Alas-alas je. Kita run.
Okay.
Itu saja.
Okay, good. But this project is because I just want you to play with the software. Okay, and I want to see how you use the timer, how you use the functions, the addressing. Okay, so whatever we learn, you see. Okay, because there's many ways to do this. Because your program is different, right? Whatever you done, you save first. And tomorrow we continue with other functions. And we go to intermediate to advanced level. Tomorrow we will be doing HMI as well. HMI, we use this one, PLC. We review this HMI.
This one can use with AB system.
Any HMI. Normally HMIs are can support to more multiple brands.
Like Siemens and AB.
This one can support Siemens, AB, Omron, Mitsubishi. even directly can support to VFD also can. Because they are like HMI manufacturer. They don't have PLC in tech. So like some HMI models which they are very specialized on HMIs. Their graphics very nice. They are more support nice. The touch also nice. If let's say Allen Bradley HMI is made for Allen Bradley, but it can support to other PLC also. But if you see, they don't widely use for other PLC, mainly for Allen Bradley.
So this one,
WinTech
fintech,
or WinView we call it.
WinView.
Yeah, WinView is Asia market lah because China won. WinTech is for US market. But the WinTech they made in Taiwan, but the software is the same thing. Can you check with your HR for the PO? For your PO, yeah.
Because I don't have company access. Maybe I can text him.
That is where.
Oh yeah.
Never mind, I will WhatsApp.
Yeah, I sent the email already. Just a reminder.
Because usually it takes few days.
Yeah. Because last week
We
Friday,
have few level to approve.
yes. So last week Friday only we sent vendor registration.
Okay, thank you.
Thank you.
Okay.